Okay, so I have a polynomial p of x and three values for x naught, 0.1, 0.01, and 0.001. I want to calculate the exact value of the polynomial at each of these 3 points, the first partial sum for each of these 3 points, the second partial sum for each of these 3 points, and then also the error values for these. So I'm going to do everything for 0.1 first, then I'll go through and do everything for 0.01, and then I'll go through and do everything for 0.001. So first, when we plug in 0.1 into our polynomial, you can do this in your calculator if you want, but the numbers aren't that bad, so I went ahead and did it by hand, and I get 1.589. Next, we're going to consider the first partial sum, and remember that's the terms, that's the constant term and the x term, x to the first power. So in this case, that's going to give us 1.5. And then when we're thinking of the error, we're thinking about everything else. So in this case, the error works out to 0.089. For the second partial sum, we'll do the same thing. But now we're looking at the first 3 terms. So our second partial sum comes to 1.56. And then the error is just the 2 remaining terms. So in this case, that's 0.029. Next, we'll do the same thing. We'll plug in 0.01 into everything. This is getting a little bit more complicated, but again, you have calculators, so you'll be fine. And it works out to 1.950593, a nice round number. So now the first partial sum, again, it's the first 2 terms, the constant term and the x to the first term. And in this case, that'll work out to 1.95. And the error then is everything that's left over. So that's 0.000593. Now, for the second partial sum, we're looking at the first 3 terms, and that'll be 1.9506. The error is the last 2 terms, but in absolute value. Errors are always positive. It doesn't make sense to talk about a negative error. And so in this case, that's going to be the 0.000007. So that is our error for our second partial sum. And we're going to do the same thing for 0.001, but I'll run through it pretty quickly because it works out the exact same way. So I'm going to plug in and I'm going to get a pretty horrendous number. Again, you can do it in your calculator. The first partial sum, I'm just looking at those first 2 terms, 1.995. And the error is very tiny, you can see already. And then the second partial sum is the first 3 terms, and that error is very minuscule. If you just added the last 2 terms together, you would get a negative, so remember to take the absolute value again. And now here's the everything that we found. So you can see the function value for each of these, and then the first partial sums and second partial sums, and the errors. So you can see that as we get closer and closer to 0, our errors get smaller and smaller. And also as we go from the first partial sum to the second, our errors are getting smaller and smaller as well. So you could see that if we went to the third partial sum, we would be even closer.